choking grounding is a device designed to reduce the flow of high-frequency currents. It's often implemented as an inductor, which is essentially a coil of wire. When current passes through this coil, it generates a magnetic field. The main purpose of chokes and grounding systems is to prevent or mitigate the flow of high-frequency currents through grounding conductors. These currents can originate from various sources, including electromagnetic interference, or EMI, electrical noise generated by electronic equipment, and even lightning strikes. By effectively blocking these high-frequency currents, chokes help maintain the integrity of grounding systems and prevent potential damage to sensitive equipment connected to those systems. Now let's talk about when it's appropriate to use chokes. Firstly, chokes are commonly used in grounding sensitive equipment. Installing chokes in the grounding conductors of sensitive electronic devices can provide a layer of protection against EMI and electrical noise. This is especially crucial for equipment that is easily susceptible to interference, such as medical devices, laboratory instruments, and high-end audio equipment. Secondly, chokes can be used for separating grounding systems. In situations where multiple grounding systems are in place, chokes can be employed to isolate these systems from one another. This prevents high-frequency currents from circulating between them, which can lead to unwanted noise and potential equipment malfunction. Thirdly, chokes are useful for eliminating ground loops. Ground loops occur when multiple paths exist for current to flow through grounding conductors. These loops can introduce noise and instability into electrical systems. Chokes can be strategically placed to break these ground loops, thereby reducing noise and improving system performance. Now let's explore the different types of chokes used in grounding. Firstly, there are inductive chokes. These are, as mentioned earlier, coils of wire designed to create inductance. Inductance is the property of a circuit element that opposes changes in current. Inductive chokes are effective at blocking high-frequency currents due to their inductive reactance, which increases with frequency. Secondly, we have ferrite chokes. Ferrite chokes are constructed from ferrite material. Ferrite is a ceramic material that exhibits low electrical resistance but high magnetic permeability. This combination of properties makes ferrite chokes particularly effective at suppressing high-frequency noise. Thirdly, there are common-mode chokes. Common-mode chokes are specifically designed to suppress common-mode noise. Common-mode noise is a type of interference caused by currents flowing in opposing directions onto conductors. These chokes are constructed with two identical windings on a common core, which cancels out the magnetic field produced by differential mode currents while allowing the magnetic fields produced by common mode currents to reinforce each other, thereby effectively suppressing the noise. Now let's talk about the installation and maintenance of chokes. Chokes are typically installed in series with grounding conductors. This means that the grounding conductor is cut and the choke is inserted into the circuit, allowing all grounding current to flow through the choke. It's crucial to size the choke appropriately for the specific application and the expected frequency of the currents it will be suppressing. The choke's inductance and current carrying capacity should be carefully considered to ensure optimal performance and prevent overheating. Regular maintenance is essential to ensure the effectiveness of chokes over time. This includes several key steps. Firstly, visual inspection should be conducted to check for any signs of damage or corrosion. Look for cracks, breaks, or discoloration in the choke's housing, as well as any signs of corrosion on the terminals or leads. Secondly, testing should be performed to verify the choke's inductance. An inductance meter can be used to measure the choke's inductance and compare it to the manufacturer's specifications. A significant deviation from the specified inductance may indicate a problem with the choke. Thirdly, cleaning is necessary to remove any debris or corrosion that may compromise performance. Use a soft brush or cloth to gently remove any dirt, dust, or corrosion from the choke surface and terminals. For stubborn corrosion, a specialized electrical contact cleaner may be used. It's important to follow the manufacturer's instructions when using any cleaning products. So let's recap. A choke is essentially an inductor used in grounding systems to reduce high-frequency currents. These currents can come from EMI, electrical noise, and lightning strikes. Chokes are useful when grounding sensitive equipment, separating grounding systems, and eliminating ground loops. Types of chokes include inductive chokes, ferrite chokes, and common mode chokes. To install, place in series with grounding conductors, and maintenance includes visual inspections, testing inductance, and cleaning. Let's dig deeper into the characteristics of inductive chokes. Inductive chokes, at their core, are coils of wire. The inductance of a coil is determined by several factors, including the number of turns in the coil, the diameter of the coil, the length of the coil, and the permeability of the core material. A higher number of turns, a larger diameter, and a core material with higher permeability will all increase the inductance of the coil. The inductive reactance of a choke is the opposition it presents to alternating current. This reactance is directly proportional to the frequency of the current and the inductance of the choke. The higher the frequency of the inductance, the greater the reactance. This is why inductive chokes are effective at blocking high-frequency currents while allowing low-frequency currents to pass through relatively unimpeded. Ferrite chokes are unique because of the material they are made from. Ferrite materials are ceramic compounds made from iron oxide blended with other metallic elements. These materials have a high magnetic permeability, meaning they can easily concentrate magnetic fields. This property makes ferrite chokes very effective at suppressing high-frequency noise. They are often used in applications where space is limited, as they can provide a higher level of noise suppression in a small package. Common mode chokes are specifically designed to address common mode noise, which is a type of interference that can be particularly troublesome in electronic circuits. Common mode noise is characterized by currents flowing in the same direction on two or more conductors. This type of noise can be generated by a variety of sources, including power supplies, switching circuits, and external electromagnetic fields. Common mode chokes work by creating a high impedance path for common mode currents while allowing differential mode currents to pass through relatively unimpeded. This is achieved by winding two identical coils on a common core. When differential mode currents flow through the coils, the magnetic fields they produce cancel each other out. However, when common mode currents flow through the coils, the magnetic fields they produce reinforce each other, creating a high impedance that effectively suppresses the noise. When selecting a choke for a specific application, it's important to consider several factors. Firstly, the frequency range of the noise that needs to be suppressed should be considered. Different types of chokes are more effective at suppressing noise in different frequency ranges. Secondly, the current carrying capacity of the choke should be considered. The choke should be able to handle the maximum current that is expected to flow through the grounding conductor without overheating or saturating. Thirdly, the inductance of the choke should be considered. The inductance should be high enough to provide adequate noise suppression, but not so high that it introduces excessive impedance into the grounding circuit. The physical size and mounting requirements of the choke should also be considered, especially in applications where space is limited. Finally, the cost of the choke should be considered, as different types of chokes can vary significantly in price. Proper installation is crucial for ensuring the effectiveness of chokes. Firstly, the choke should be installed as close as possible to the source of the noise or the equipment that needs to be protected. This minimizes the length of the grounding conductor that is exposed to the noise. Secondly, the choke should be securely mounted to a solid surface to prevent vibration and mechanical stress. Thirdly, the connections to the grounding conductor should be made using low impedance connectors to minimize voltage drop and ensure good electrical contact. Finally, the grounding conductor should be properly sized to handle the maximum current that is expected to flow through it. Regular maintenance is essential for ensuring the long-term performance of chokes. Firstly, visual inspection should be performed on a regular basis to check for any signs of damage or corrosion. Look for cracks, breaks, or discoloration in the choke's housing, as well as any signs of corrosion on the terminals or leads. Secondly, the choke's inductance should be measured periodically to verify that it is within the manufacturer's specifications. A significant deviation from the specified inductance may indicate a problem with the choke. Thirdly, the connections to the grounding conductor should be checked to ensure that they are tight and free of corrosion. Loose or corroded connections can increase the impedance of the grounding circuit and reduce the effectiveness of the choke. Finally, the choke should be cleaned periodically to remove any dirt, dust, or other contaminants that may accumulate on its surface. Let's consider some practical examples of how chokes are used in grounding systems. In a hospital, sensitive medical equipment such as MRI machines and CAT scanners are highly susceptible to electromagnetic interference. Chokes are often installed in the grounding conductors of these machines to protect them from noise generated by other electrical equipment in the building. In a data center, servers and networking equipment are critical for business operations. Chokes are used to isolate the grounding systems of different equipment racks to prevent ground loops and reduce noise that could disrupt data transmission. In a broadcast studio, audio and video equipment must be protected from noise to ensure high-quality recordings. Chokes are used to filter out noise from power lines and other sources of interference. In an industrial plant, machinery and control systems can generate significant amounts of electrical noise. Chokes are used to suppress this noise and prevent it from interfering with other equipment. The specifications of a choke are critical to understand for effective implementation. The inductance value, typically measured in henries or millihenries, determines the choke's ability to impede high-frequency currents. Higher inductance values generally offer better suppression at lower frequencies, while lower values are more effective at higher frequencies. The current rating, measured in amps, indicates the maximum continuous current the choke can handle without overheating or failing. It's crucial to select a choke with a current rating that exceeds the expected maximum current in the grounding conductor. The DC resistance, measured in ohms, represents the resistance of the choke's winding to direct current. Lower DC resistance is desirable as it minimizes voltage drop and power loss. The self-resonant frequency, measured in hertz or megahertz, is the frequency at which the choke's inductance and parasitic capacitance resonate, causing it to lose its effectiveness. It's important to choose a choke with a self-resonant frequency that is well above the frequencies you intend to suppress. The impedance, measured in ohms, is the total opposition the choke presents to alternating current at a specific frequency. It's a combination of the choke's resistance and reactance. Higher impedance generally indicates better noise suppression. The tolerance, expressed as a percentage, indicates the allowable variation in the choke's inductance value. Lower tolerance is generally better as it ensures more consistent performance. The operating temperature range specifies the range of temperatures within which the choke can operate safely and reliably. It's important to choose a choke with an operating temperature range that is suitable for the intended environment. The size and mounting style of the choke should also be considered, especially in applications where space is limited or where specific mounting requirements exist. The core material, such as ferrite, iron powder, or air, affects the choke's performance characteristics, including its inductance, current carrying capacity, and frequency response. Ferrite cores are generally preferred for high-frequency applications, while iron powder cores are better suited for high-current applications. The construction style, such as toroidal, drum core, or rod core, also affects the choke's performance characteristics. Toroidal chokes generally offer better performance and lower electromagnetic interference, while drum core chokes are more cost-effective. To summarize, chokes are essential components in grounding systems for mitigating high-frequency currents and protecting sensitive equipment. Understanding the different types of chokes, their specifications, and proper installation and maintenance practices is crucial for ensuring their effectiveness. By carefully selecting and implementing chokes, you can significantly improve the performance and reliability of your electrical systems.